timber framing detail, where we're looking at 2D wall sectional detail, which includes the wall, its connection with the roof and ceiling, and the connection with the slab or framed floor, we've primarily just been focusing on a single story residence where we're not paying any attention to a first floor. That's what we're going to do now. So we're going to copy this detail. We'll move it across 10 meters like the other one was. And we're going to turn this into a 2-story detail. So in order to do that, we're in essence saying that that fill doesn't exist, and we're not really overly interested in what's happening from that connection, what's happening from this connection. We're going to add something in the middle. Now we may actually do this slightly differently, or another way of saying that is we might add some more weatherboard for part of this, or we could have brick. It doesn't really matter. Now, what we're assuming here is that we're saying that there is a top plate of, let's move this down a touch. Edit, reshape, stretch. And we'll stretch this one down. So we have our insulation for our ground floor story. And then we need to have a break. What I tend to like doing is just breaking all of this here, and this makes life a lot easier rather than having to make it all stretch. So we'll just start by removing a section here, and then we can add it back later if necessary. Now, instead of having a framed floor out of pine, we're going to use a engineered timber. The engineered timber that we're going to use is called a high joist, and sometimes it's got other names than that, but it's a block of timber. In this case, we're going to use one that's 90 by 45. And then there's another block of timber. And so these form the flanges. And then there is a piece of ply in the middle, which is what this was supposed to be. I forgot to change it. So let's change this to plywood. And that's supposed to be rotated. So we'll copy this. And we'll make this a bit wider. So we'll make this 12 mil. So we'll go additional 3 that way, additional 2 that way. And it's normally recessed not quite the half of the timber. I'm going to turn off true line weight for a second to make this easier to see. So we're going to recess this in 15 millimeters. And we'll recess this in 15 millimeters. And we'll just chop that out. And chop that one out. Now I could get rid of these X's if that's not making a lot of sense. I could replace that with dressed timber, if that was a little bit easier to understand. The reality, it's not really dressed like that. It is still more just a structural element, but this might be slightly easier to comprehend. So this is what our high joist looks like. Of course, we could add a color on the back of that as well. Let's check that out. And this is in section, so we'll make the outline a little bit thicker as well. Great. So let's group that together. That's our high joist. Now the idea is that this is our main structural element for the first frame floor. Now you might say this isn't really strong, and yeah, that's true. It's not really strong. The point is that it doesn't need to be as strong as it is tall. In this case, it needs to be tall so that it can allow for things like plumbing traps and air conditioning ducts, we could get away with spanning most first framed floors with maybe a 200mm beam. But in this case, we're going to use a 300mm beam so that it has the ability to not just span a long way, but also to be able to take those other services. I like using this larger flanged section, the one with a 90mm flange. It just makes construction easier. It's not considerably more expensive, and of course it's a little bit stronger than the 45 or 63mm flanged version. Now, depending on which way we're looking at this detail, or depending on which way the floor is being cut, our joist is going to sit here, and then it's going to be multiplied at something. So at 600 centers, 450 centers. And so we may be seeing it in this direction. In this case, I won't make it viewed in this direction because that's hard to tell, hard to understand. So instead we'll see it in the other direction. So it's going to be spanning this way. So in order to represent this, I'm going to draw this same high joist, but I'm going to draw it in elevation. So of course it looks like that, and basically like that. So this is our high joist in elevation, and therefore what this is doing is creating blocking. So what we're seeing is the blocking between. Now in order for that to be blocking between, we should also see another bit there. Now we're missing the bottom plate of the next, so let's copy this one. Now we don't want the bottom plate to sit directly on the floor joist. Before we have the floor joist, we're going to have our structural flooring. So I'm going to go up 19mm, and that's going to allow for 19mm of plywood. So just like we had plywood here, we're going to copy this ply. Let's just do that and do that before we start, just so that's easy to understand. I'll copy this plywood, move, drag a copy, rotate, and I don't need to have the fill in the same way, so I could turn fill back to normal. So it's going to sit here, and I want this plywood to be 19mm thick. We'll extend this one all the way through, and that's our structural flooring. Now on top of our structural flooring, we'll also have something else. And so that could be carpet, or it could be tile, like I had down here. Now I wouldn't be using plywood if it was a bathroom, but if it was a living space or a bedroom, let's say I wanted it to be tiled, I could do something like that. Similarly as before, in order to make this work, once we have a thicker flooring, so let's leave that as at the moment. So I could double up this bottom plate and leave a bit of a gap with my plasterboard, and then I could add a skirting board down here. How do we do the ceiling? Now the ceiling could be plasterboard direct stick to the underside of this, or we can do the same detail as over here. So that's what I'll do in this case. Copy this down. My intention, of course, is just to make this easy for myself and make it fast for you to be able to recreate as well. So just by looking back at another video to see how we and why we did this effectively. So this allows the plasterboard to run up past. This means then the batten also means that if there's any inconsistencies with the set out of these high joists, the batten will reduce any inconsistency so the plasterboard can be flatter and will reduce the likelihood of cracking. Just like I've got this fill here, which is breaking the wall, I'll then need to do the same thing here. Now this is not representing really well at the moment, is it? Generally speaking, I will want the brick to stop somewhere. That might be the top of the floor, or it might be the bottom of the floor down here, and then I'll have my weatherboard extending down. Now, typically I'm probably going to try to relate that to a datum, something that makes sense on the outside of the building. I could have this brick running the whole way up, or I could have this brick stopping. So it doesn't really matter is the point, and we can do it in a few different ways. So let's, just to make this simple at the moment, run this down, and we're going to use the bottom of our floor to define the edge of this. And we're going to run this all the way down just so it's consistent, and we'll be running the sarking or the membrane all the way down. Now I get to show you how we finish these at the bottom. So let's copy all these, and we'll go move, drag multiple copies using that as the reference point. And I always just do more than I need, and then I can quickly delete any leftovers. So I don't need this one, don't need this one, and obviously this one is only half. So we'll chop that off. And I also want to leave a little bit of a gap. I don't want to have weatherboard touching the brick, so let's leave a 10 mil gap there. And then it's a question of how this is finished, because of course this isn't going to work, is it? So we need some type of, again, blocking like we had up here, packing. Now typically we could use a proper packer. In this case, what I'll do is use a larger block of timber, and this would be cut to fit perfectly to size. So we'll stop the vertical batten, that'll turn into horizontal batten, and that'll be cut to size in order to be able to put this in the right position so the angle is consistent. Now I need to get a little bit more detailed here. So I've got my sarking. I don't want this sarking just to run the whole way down. I want to have some type of flashing. So I could have a hard flashing, so a folded ColourBond flashing, going from the outside of the brick, so over the edge of the brick. That will then sit behind the sarking. Let's make that 4. And then of course the sarking would start again here. So this is acting like the weep hole, like we have in the bottom of the brick. In this case, the folded capping is also creating this overlap between the brick and the cladding. Now we could say, I don't like the look of that detail. I don't like the fact that this brick is sticking out a long way and the weatherboard is set all the way back. Now this is common, but if we wanted, we could of course pack all of this weatherboard out so it was flush with the outside of the brick. But in order to do that, we'd need a much larger batten. In this case, I really don't care. I'm happy to have this spaced. There's one more detail that I need to explain in terms of this capping, and that is, in order to make this capping look nice, I don't just want to finish like this either. I actually want to double this back, or fold this back, and that'll make this capping significantly stiffer by having a crunch fold on the back. Now this capping needs to go up higher. It needs to be about 150 mil at least, and I'll stop this short just to explain what's happening there a little bit more clearly. And so now I'm transitioning from brick veneer to timber frame and clad. In this case it's a horizontal weatherboard, and that weatherboard is made out of fiber cement. So of course we could substitute any of these other finishes that we've been talking about. So it could be a quad gutter, it could be a flat soffit, it could be Hebel cladding. It really doesn't matter. These are all now external systems which can then just get plugged into our timber frame structure. To finish this off, let's extend this insulation. We also need our ceiling insulation, so I'll copy this across. There's a few little things that I had missed before or hadn't explained very well. One of those is brick ties. So when we have a timber frame wall, we also need to connect the brick into the timber frame. The brick on its own could be structural, but because it's a single skin brick, it's not very good at being structural. So in order to be able to make it strong or not fall over, we're going to tie it into our timber frame, which in this case is the structure. Generally, we need brick ties every 6 courses. Because I can't see that, I'm just going to add one here. And what that brick tie will look like in this particular instance is it will be bedded into the mortar bed. And then I want it to have a bit of a kink. That's going to allow water to drain if it's running along. Sorry, let me finish this and to make a bit more sense. Any water that's running through the brick is then going to drip down the cavity rather than running all the way to the wall. And then I'm going to have the tie, which then gets screw or nail fixed into a stud. So I could just change that to be a center line or a dash line. And that's our brick tie. And of course, we'll have another one further up. So we can repeat this. So let's just put one here just for the sake of representation. Now I'm still missing some information. So how am I providing termite protection? In this case, it's very possible that we could have termites coming from the ground, going through this mortar joint, going up here and into the building. So I'll typically require one of a few different solutions. So I'll need some type of membrane, which is going to make them not want to climb up here. I'm going to need to have, so that might be cordon, so a plastic with chemical impregnated in it, which is, not really nice for termites. Or we might have granite guard, meaning that it's a physical barrier. They can't climb through the granite is the idea, the little bits of granite. Or we might have a termi-mesh. And the idea of a termi-mesh is that it's similar to the granite guard. In this case, it's woven stainless steel with a really tiny aperture, and it stops the termites from climbing through that as well. So that's the 3 most common methods of how we would do this approach. Now, if I was doing cordon, I'd probably just use a thick line, a really thick line. I'd probably make it dashed. And I would be showing that that is fixed to the downturn here. It'll be sitting underneath my flashing. And so it'll be a second layer, basically, something like that. And that cordon will extend through here a little bit. So we could have a cordon finish. We could have a granite guard. The granite guard will basically be a little tiny gravel. It's going to be hard for me to represent that, so I'll just represent that as render at the moment, and that will fill up the bottom of this space. And I might just change the colors of that. Let's make it real dark. So that could be my granite guard. And the termi-mesh would be similar. So the termi-mesh might be underneath here. Typically I want it to go outside as well. And it's going to continue up underneath and prevent the termites from climbing in underneath that point. So these are our termite protection solutions. They're not perfect. Of course, anything's not perfect. We could, of course, have a chemical barrier outside as well. But our detail's starting to look pretty good. I'm not covering everything, but it's really just about representation at the moment. We're just building the basis of our details. And then as we keep layering up different information we need to add, we'll keep then adding a bit more information like dimensions and annotations. One of the next things that we'll be doing over the next week or so is adding a window or different types of windows into our section. At the moment, we've just been looking like we're cutting through a boring part of the wall without any windows. We'll then be looking at how we add window into this detail as well, and the different aspects of what that means for the window sill and the window head and a lintel or a structural frame, which then supports the top of that window.